Now that we've been introduced to indexer properties, let's take a quick look at mapping property bags. As we've already mentioned, they're a special case and we might not ever run into needing them. But as also mentioned, there are cases when this feature is very relevant to be aware of, and in the upcoming demo we'll take a look at such a scenario when we implement the tagging feature that we just discussed by creating and using a property bag entity.
We're now back inside Visual Studio, and we're looking at how a property bag entity is set up using the onModel creating method in the CarvedRock database context. Remember from the slides that we talked about how this was done by configuring a shared type entity on the data model. That is exactly what is happening here. And of course, as we discussed during the slides, this is not an entirely realistic scenario, since we know everything about the class that we want to create. But it serves as an illustration of how property bags can be set up. First, what we do is to set up the generic type of the shared type entity to be a dictionary of string and object, just like we did for the indexer that we used for creating indexer properties on the custom entity. The first parameter that we pass to the shared type entity method is the name of the new entity type that we will be defining. In our case, we pass in the name tag. Following this, we pass in an anonymous method where we configure the new type. Here we first configure an entity property called ID on the entity. This is followed by another integer property called customer ID, a string property called nickname, and finally an integer property called discount rate. Remember from the slides that if we created a code first migration for this, the ID property will be mapped to the primary key of the new table which will be created. And also note that just like we saw with the indexer properties, we're able to add restrictions to these properties, such as for example max length, just like we would for any other property on an entity that was backed by a class in our model. And if we take a look here, we can see that a collection has been added which will allow us to query the data in the new tag table that we'll be creating in the database. This collection is created a little differently from the other collections on our database context. First of all, there's of course the generic type of the collection, which is a dictionary of string and object. And also instead of getter and setter methods, it just has a getter which returns a call to the set method. The set method is a method on the database context, which we can use to create a DB set for shared type entities. In the code that we see here, this is done by setting the generic type on the method call to be dictionary of string and object and passing in the value tag to make sure that it uses our new shared type entity. If we now add a new migration for this using the add migration command in the package manager console, we'll get a new migration file that we can see here. As we can see, the table is set up just like we would expect for any entity in our data model. And as we can see, the new table will be named tag and contains all the fields that we configured for it. Also notice here that as mentioned, the ID property is set to be the primary key for the new table. If we now apply this migration to the database, we can head over to the Server Explorer and take a look at our new table. And as we can see, the table has been added with all the appropriate columns. And if we take a look at the contents of the table, we can see that it is empty just like we would expect. But let's head over to our program class in the console application and change that. The first bit of code that we see here creates a new tag instance by creating a dictionary of the type that we know so well by now. Notice here that the customer ID is set to 4, which corresponds to the first John Doe in our database. As mentioned, this is not a proper foreign key relation, so there will be no validation that it matches any customers, but if used correctly, it can still serve the same purpose. Next, we add the nickname something funny and a discount rate of 10 to the tag. Just like we did when we looked at indexer properties, we also add an entry with the key not defined, which will not be saved when we call save changes. Then we add the new tag to the tags collection on our data model and call save changes on the database context. And then here in the next line, we fetch our newly added tag from the database. And these two following lines of code here change the nickname on the new tag instance to something funnier and save that change to the database. Now let's try to run this code and see it in action. First we create the new tag as we discussed, and if we advance the debugger a few steps, it is added to the tags collection on the database context and save changes is called, persisting it in the database. If we now take one step further, we fetch the tag back from the database and can take a look at it here in the watch view. As we can see here, all the fields have been assigned as we would expect, and we can see that our new tag has been assigned an ID of 2, which was added when we called save changes. If we head over to the Server Explorer and take a look at the contents of the tag table, we can see that it now has our new entry with the ID 2, customer ID 4, discount rate 10, and the nickname something funny. If we now head back to our program code and advance the debug a few steps, the nickname is updated to something funnier and we call save changes on our database context. If we now head back to the Server Explorer and take a look at the data, we can see that the nickname has been updated to something funnier. This was just a quick primer on property bags. We will revisit them once we look at many-to-many relationships to see that this is how if Core implements the intermediary table for a direct many-to-many relationship. In the demos that we just watched, we saw how to map indexer properties in our AF Core data model. We saw how we can use these indexer properties to extend our entities by adding new properties to them without changing the code of the actual entity classes. There may be various reasons why we would want to do that. The most obvious one would be that for some technical reason we were not allowed to change the classes, or they exist in a codebase that we do not have access to. Whatever the reason, indexer properties gives us a way of extending our data model despite such restrictions. The extreme end of that issue would be that no entity class existed at all, and the information for creating our table comes from external data such as a JSON settings file. In that case, we can use property bag entities to create and interact with tables in our database. As we just saw in the demo, property bags are not backed by an entity class, but are simply mapped to a collection of dictionaries that we can use to fetch data from the underlying database table. As we saw with the tags example, when we query tables that are mapped in this way, each entry in the table is returned to us as a dictionary of string and object, where the string value is a key which contains the name of the table column, and the data in the column is stored in the value property on the dictionary entry. Another special case that is interesting to take a look at is owned entity types. Basically, an owned entity type is an entity that can only appear as a navigation property of other entity types, so that the owned entity type is owned by entities on which it appears as a navigation property. In that sense, owned entity types only exist in the context of the owner and are fully dependent on these. So an owned entity type is essentially a part of its owner, but it can be thought of as a separate entity within the owner. An example of this could be an entity to store addresses for CarvedRock customers. Such an entity might very well be defined as its own fully fledged entity with a table to back it and a foreign key relationship with the customer's table. But it could also be implemented as an owned entity, as we shall soon see in the demo. But why would we want to implement such properties on a separate type rather than as a field directly on the owner? Well, the primary reason would be that such an owned entity type can be reused. For example, we might imagine that a customer has both a ship to and a sell to address. Each of these could be mapped to our owned entity as a navigation property. And also an owned entity can be used across several other entities so that it can have multiple owners. This could be relevant, for example, if another entity within our data model also needs to have address information attached to it. Another advantage is that it helps keep our entity classes clean by grouping properties into owned entities, so our owner entities do not become too cluttered. However, as we shall soon see, the clutter still exists in the database, but at least using owned entity types helps keep our code clean, and if we are primarily interfacing with our database through AF Core, that is a big advantage.
And finally, for those following domain-driven design practices, owned entity types are very useful since they provide us with a way of mapping value objects so that they can be persisted in the relational database.